In this tutorial, we will take a look at some biodiversity information and how you can manipulate, access, visualize this information using R or R Studio. So basically this information is made available by Global Biodiversity Information Facility. We'll be accessing this information using rgbif package. So this package provides functions for accessing information as well as some important functions for data analysis. So before we get started, you need to install rgbif package, sf package and ggplot2. So we will take a look at these functions, that is occurrence count, name, backbone, occurrence search, some ISO codes, and we'll be plotting information using ggplot2 and sf package. You can visit their website, you can visit GBIF website. Then there is also website of rgbif package. Then I want you to download some shapefiles. So on this website naturalearthdata.com, you will get shapefile of world ocean. So just download it. Also download shapefile for world borders. We will be using these two shapefiles to make some interesting spatial plots. I have already downloaded these two, so I won't be downloading it again. Download and extract the contents of these two zip files. So this is shapefile for ocean and this is shapefile for world borders. So using these two, we will be creating interesting visualization like this. So which tells us something about distribution of species, distribution of particular species worldwide. So let's get started. First function is occurrence count. So this function basically returns the number of species available, number of occurrence of a particular species available in the database. So if you run occurrence count without any parameters, so it is simply going to tell us total number of observations available in the database. So this is summation of all the species available with Global Biodiversity Information Facility. Further, you can give parameters like basis of record, so which can be human observation. So this will return occurrence for species which were recorded by human observation. And there is also basis of record for machine observations. So we have this many occurrences of all the species for which basis of record is human observation, and this many number of species for which basis of record is machine observation. Similarly, you can also provide parameter for georeference. So the occurrences for which we have latitude and longitude recorded or not recorded. So this false is for those which we do not have lat long recorded, and true is for those for which we have lat long recorded. So this is very simple function which tells us the number of occurrences that we have in the database. So further, if you want to focus on a particular species, say Bengal tiger, then we can use name backbone function, to which we can pass the name of species along with genus, that is scientific name. So if we execute this command, we will get a list of information for this particular species. So this is the list, and in which we have all the taxonomy for Panthera tigris. These are the keys. So at every level, a key is associated with the species. These keys are very helpful to refer to a particular species using number instead of name. So once we have this list for Panthera tigris, we can take a look at key for this species. So species key, which is 5219416. So we can use this key to access some more information for this particular species. Further, you can also specify a particular kingdom for which you want some information, say Animalia. So this will provide list for Animalia kingdom. This is data in form of list for Animalia. This is the kingdom and the key associated with it is 1. So even in tigris, if you see, the kingdom key is 1 because tiger again falls under Animalia kingdom. So similarly for neem tree, which is a plant, you can get list of all the details. So the kingdom is Plantae and kingdom key associated with it is 6, and species key is 3190474. So using these keys, we can find out how many occurrences of a particular species are available in the database. Suppose for kingdom Animalia, the total number of occurrences which we have is, then for Panthera tigris it is 1805. Similarly, we can provide other parameters along with taxon key. So the number of observations for the number of observations for Panthera tigris, for which we have georeferenced, is 577. Then the number of observations of Panthera tigris, for which the basis of record is human observation, is 95. So basically this is the key. You can directly provide the number as taxon key, which will give a same output, 1805, 1805. So here in this list, which has some details about a particular species, but this is not the actual data. So this tells us only about the taxonomic classification and the keys associated with it. But this is not the actual data. To download actual data, we will be using occurrence search function. So to this function, we can provide taxon key, then return type is data, and the limit. So 2000 is maximum limit to access any data using this package. So if we execute this command, so now here we have actual data for Panthera tigris, that is the Bengal tiger. So all 1805 observations are retrieved in this using this query. So there are many columns or fields associated with each observation. So for we have key. This key is different from the taxon key. So you must be careful while regarding the key. So this key is completely different. This for every observation in this data set, which is of Panthera tigris, different key is available. So this is the actual species key, which is same. Then in this data we have information like latitude, longitude, then the publishing country, then of course taxonomic classification, year, month and day when the observation was made, date identified, event date, modified date, references, etc. Alternatively, you can also access information or data of any species using this scientific name parameter. So if we execute this command, so we have data, so we have got list over here, and in that list data is available. Here in this command we had specified return type as data, but since no return type is specified over here, all the information is made available. So here we have data. Since limit specified over here was 20, so we have only 20 observations. The package also provides ISO codes for countries. If we want to focus on any particular species in a particular country, then this can be helpful. Suppose we are interested in all the animals in India, so ISO code for India is IN. Then we can specify a taxon key. Alternatively, we can also use scientific name, then return type as data, the country code and limit. So if we execute this command, it will return this data which has all the different species. So these are all different species. Since we are interested in all the species in Animalia kingdom falling in country India, so it has randomly sampled some species. So we have got total 832 different species from India. We will take a look at how can we visualize this information. So using SF package, we can load the shape files which we had downloaded at the beginning of the tutorial. So just provide path name, file path in this st underscore read function. So we need world borders as well as world ocean. Now we can visualize this using ggplot2. So shapefiles are provided in geom sf function, and the lat long for Panthera tigris are provided in geom point. So if we execute this command, we will get visualization of spatial distribution of tiger species. Only those species for which lat long is available will be shown. That is the occurrences for that is occurrences which are georeferenced. So here is the distribution of tigers around the world. This point over here is zero latitude and longitude. So this is basically data cleanup error. So further, we can also access specific species based on genus name. So this is genus for salmon fish. So if we execute this command, these are all the observations for Oncorhynchus genus, which is of salmon. So species might vary, but the genus is same. You can plot this as well. So all the observations near land or on land are available, but we do not have any observations in the ocean. Since previously we had produced visualization for distribution of tiger species, so we have some data for prey, that is antelope, Indian buck, which is common prey for tiger. So we can download this data as well and visualize it with tiger data, that is prey predator distribution. So now we have predator as tiger and prey as antelope, and if we plot their occurrences, prey and predator distribution. So the red one are tigers, the blue are bucks or antelopes. We can do other studies like the year in which the occurrence was recorded. So for tigers, this is the frequency distribution for years in which observation or occurrence was recorded. Similarly for antelope, this is for tigers and for antelopes. So that is it for this tutorial. So do not forget to like and subscribe if you enjoyed the video, if you find it interesting and helpful.